Nice to meet you. I'm Khizar Chuktai and you're watching my YouTube channel School of Advanced Chemistry. I'm going to explain Hess's cycle or Hess's law. How enthalpy change of a chemical reaction is calculated with the help of enthalpy cycle or Hess's cycle or Hess's law, especially when we are unable to perform an experiment to calculate that enthalpy. For example, there are many enthalpy of formations. Those cannot be calculated directly or with the help of experiment. For example, enthalpy of formation of carbon monoxide is quite difficult to calculate experimentally. So we are using basically different routes or indirect routes to find the enthalpy of formation of carbon monoxide. That is the basic application of Hess's law. So Hess's law states that enthalpy change of any chemical reaction is independent to the path followed by that chemical reaction. But initial and the final condition should be same. So enthalpy change of any chemical reaction is independent on the path of reaction. That is, if our reaction is happening in a single step, or if we are going to divide that reaction into more than one step in multiple steps, then the total enthalpy change of that reaction will remain constant. So enthalpy change of a chemical reaction is independent to the path followed and independent to the time followed or time taken by the different step. So enthalpy change is a state function and it is going to depend on the initial and the final condition of the system. So this is the simplified version of Hess's cycle or Hess's law. Basically, Hess's cycle is applicable when the different equations are given, or when different reactions are given, or when a cyclic process or the cyclic question is given, or the cyclic theme is given basically. And whenever we are unable to do experiment, whenever we are incapable to do any experiment to find the enthalpy of formation or enthalpy of combustion experimentally, then we use Hess's cycle or Hess's law. I'm going to tell you the Hess's cycle with Khizar's method, with the different method, so it will be easy to you as far as my opinion is concerned. Just have a look. For example, A is converting itself into D. This is called direct route. If A is converting itself into B, B is converting into C, and then C is converting into D. This blue line steps are called indirect route or indirect steps. So the enthalpy of direct route, A is going to D. This is the final destination, you can say, this D. A goes to D, this is the direct step, and if A is first changing itself into B, then B is changing itself into C, and C is changing itself into D. This is called indirect route, indirect step or indirect routes. So according to the Hess's cycle or Hess's law, let's suppose delta H R mean a enthalpy change for a general reaction, R mean a general reaction, and let's suppose first step enthalpy is delta H1, second step enthalpy change is delta H2, third step enthalpy change is delta H3. So according to the Hess's cycle or Hess's law, delta HR will be equal to the sum of all indirect route. Delta H1 plus delta H2 plus delta H3 and so on. This is the saying of Hess's law. So with the help of Hess's law, we can connect different reactions, different equations if they are having common entities. If two or more than two reactions, if are three reactions, four reactions, if they are having mutually common entities, then we can connect them into a cycle and we can find the answer of missing enthalpy or missing enthalpy change of a chemical step or the chemical reaction. There is another example, you can say an analog of Hess's law. For example, a boy is sitting on the roof of a room, a house, you can say. A boy is sitting on the roof of a house, or a room, and he wants to jump towards the ground, or on a normal level you can say here, if it's coming and he is coming from different steps till the grounds. So there are different steps for this boy to come down, and the second direct option is this one. It can come directly to the ground. In both cases, if a boy is jumping directly to the ground, let's suppose enthalpy change is equal to 100 kilojoules, and if he is following the steps, step number 1, let's suppose, step number 2, step 3, step 4, step 5, and finally he is on the ground on the same level, the enthalpy change will also be equal to 100 kilojoules. So sum of all these steps, enthalpy of step 1, step 2, step 3, step 4, step 5 will also be equal to 100 kilojoules. So this is the basic mean of the theme of Hess's cycle or Hess's law. Now I'm going to solve different questions from the past paper to explain Hess's cycle or Hess's law. This is the question number 9 that is taken from May June 2024 1 variant. An energy cycle is shown over here. He has made already a cyclic sequence X, Y, and Z. Energy change involved are X, Y, and Z. Numerical value of the energy change Y is either minus 890 or plus 890. Numerical value of energy change Z is either minus 964 or plus 964. Which of three values are negative? And here are the 4 options. So first of all, just have a look. What are these reactions basically? Number 1, X. This CH4 and oxygen, they are meeting together to make different elements. So it seems that its enthalpy change should be positive. But what about Y? If CH is going to combust itself to make CO2 and H2O, and the combustion reactions are exothermic, so its answer is negative. Enthalpy change of Y must be negative. Same is the case in case of Z. And this reaction, if I'm going to see the whole reaction, this reaction is the combustion of carbon, combustion of hydrogen, and they are finally going to make CO2 and H2O. So again, Z also be the negative. So these both values must be negative. Now what about X? I'm putting the value of Y and Z, and I'm going to find the answer of X. In this case, in this sequence basically, I'm going to apply Hess's cycle. Hess's cycle is applied by my method, by Khizar's method. That is, let's suppose these 3 reactions are behaving like a vectors, and I'm going to find a resultant vector from these 3 vectors. Which one vector, X, Y, and Z, is going to behave as a resultant vector? What is the resultant vector? A vector that is having connection of its head with the other vector's head, and its tail is connecting with the tail of other vector. So in this scenario, this Y is behaving as a resultant vector. And if the Y is resultant vector, then I'm going to find the answer of resultant vector. I'm going to applying the sum of vector rule. So in this case, the Y will be equal to X plus Z. I'm going to add all other vector, and their sum will be equal to the Y. What is the answer of Y? Y will be taken negative. It is minus 890, and we are going to find the answer of X. What is Z? Z is minus 964. What will be the answer of X? So I'm going to simplify, and minus 890 plus 964, and this is the larger value. So answer of X will be positive. So answer of X is positive, answer of Y is negative, answer of Z is negative. So C is the correct option. which of three values are negative. Only Y and Z are negative values. Now come towards the next question. Here is the question. It's taken from May June 2023, 1-2 variant. Question number 10. Nitrogen monoxide is rapidly oxidized to nitrogen dioxide, and here is the equation. Nitrogen dioxide can then dimerize to form nitrogen tetroxide, and here is the equation. What is the value of standard enthalpy change of reaction shown over here? This one. What is the answer of enthalpy change of this reaction? So first of all, I'm going to write this equation once again. 2NO plus O2 goes to N2O4. For this reaction, I'm supposed to find the answer of its enthalpy. Let's suppose its answer is equal to X. Now, here are different equations. This equation and this equation. There might be another one. Because enthalpy of formation of NO is given, enthalpy of formation of NO2 is given over here, and so on. So, I'm going to connect these equation with this equation. 2 mole of NO plus O2 goes to NO2. So 2 mole of NO plus O2 goes to NO2, or 2 mole of NO2. This is equation number 1. I wrote it over here. The next equation is 2 mole of NO2 goes to N2O4. 2 mole of NO2 is converting itself into N2O4. Let's suppose this is equation number 2. I wrote it over here. The next thing is enthalpy of formation of NO. Enthalpy of formation for any substance can be written like that. In case of NO, if I'm going to make or form NO, then I'm using nitrogen and oxygen element, half mole of oxygen, half mole of nitrogen, and this is the equation of formation of NO. So I am going to mark it over here, N2 plus half O2, half N2 and half O2. So for the sake of balancing, I'm using complete 1 O2 N2 plus O2 to make 2 mole of NO. And these are the elements. I'm going to basically mark them, or taking them as a single entity, or I'm taking them in a single box. So the next thing is enthalpy of formation of NO2. Same element will make NO2, 2 mole of NO2, but this time we will have to add some more oxygen into this box. So these elements are making NO2. These elements are also making NO2 and O, nitrogen monoxide. They are making NO2 and so on. So we have made a cyclic theme, or we have made a cyclic process. Here is almost, you can say, distorted tetragon. So once again, 2 mole of NO plus O2 goes to, I'm going to write this equation, N2O4, and here are the elements, nitrogen plus oxygen. Those are making 2 mole of NO, and the same elements are making basically nitrogen dioxide, 2 mole of nitrogen dioxide, and this nitrogen dioxide is going to change itself into N2O4. So I'm going to put the values of different enthalpies. Number 1, N2O2, formation of NO. Here is the formation of NO with respect to 1 mole, but I'm going to make 2 moles. So 2 multiplied by plus 91. And here is the formation of NO2. The formation is given with respect to 1 mole. So 2N2 plus 34. Here is the formation of N2O4. Conversion of NO2, N2, N2O4, and the answer is minus 28 kilojoules. Here is the conversion of 2 mole of NO2. Yes, I'm also converting 2 mole. So the moles are same, answer will be same. And here is this X. So let me check which one vector is going to behave as a resultant vector. If none of the vector is going to behave as a resultant vector, then we can flip the vector as well. So there is head-to-head meeting. Yes, it is correct. But its tail should be mixed with the tail of this vector. So we will have to flip this vector. We will have to flip this vector to meet tail with the tail, and the sequence is also correct. What is the sequence? Tail head, tail head, tail head. So now this has become indirect route and it has become a direct route. And now we will have to change the sign of this magnitude as well. If the vector is flipped, its magnitude is also flipped. Now what is the answer? What will be the X? X will be equal to minus 58, this one, plus 2 into 34, that is plus 68, plus 2 into 91, that is minus 2 into 91, 182. So what is the answer of X? The answer is minus 172 kilojoules per mole, and D is the correct option. So this is the method whenever you are going to have different equations and these equations are having common entities. So connect these equations, balance these equations, and then you can apply Khizar's method, head to tail rule method, to find the answer of missing enthalpy. Come towards another question. Here the data of formation, the data of combustion, and the data of combustion is given. So whenever the data of combustion or formation is given, again you are supposed to apply the Hess cycle. Once again I'm going to tell you, if the enthalpy of formation is given, if the enthalpy of combustion is given, then again you will apply the same method, that is called the same rule or same cycle, Hess cycle. Enthalpy of formation of methane. So this is the equation in which carbon and 2 mole of hydrogen will meet together to make CH4. This is called enthalpy of formation of methane. Enthalpy of combustion of carbon, in which 1 mole of carbon is going to react with excess oxygen to make CO2, and this is said to be enthalpy of combustion of carbon. Enthalpy of combustion of hydrogen, in which 1 mole of hydrogen is allowed to react with oxygen at high temperature, and there is formation of H2O water, and this is the balance equation, and this is called enthalpy of combustion of hydrogen. So he is asking to find the enthalpy of combustion of methane. Now I am going to connect these equation with this given equation. CH4, and here is a CH4. So we can make CH4 from the element carbon. We are using these elements: carbon, hydrogen, and oxygen. So I am taking all element in one packet, in one box. We can make methane from this packet, this box. Same is the case, there is oxygen, so oxygen into oxygen, there is no change. The formation of element is equal to 0. There is no enthalpy change when the same element is converting into another same element. There is no change. Similarly, we can form for CO2, formation of CO2 or the combustion of carbon. This equation is showing the combustion of carbon to make CO2, and this equation is showing the combustion of hydrogen or formation of water. So for the sake of balancing the equation, I am going to put 2 over here. I'm going to put 2 over here, and that's all. So all roots are balanced. For example, I'm going to mark, or I'm going to make the different portion. Reactant portion, this is the product portion, and these are the element portion. So all these portions should be balanced. If I'm going to move in this way, like that, let's suppose this is a blue arrow, and you can see one carbon, 4 hydrogen, and 4 oxygen. This root is balanced. Same is the case from this box to this blue box, including these 2 arrows. These 2 arrows are going towards the same side. So 1 carbon, 4 hydrogen, 2 plus 2 oxygen, 4 oxygen. So all roots are balanced. Now, what is the answer? And this vector, this delta HC, must be the resultant vector. So this is having connection of its head, that is meeting head to head, but its tail is not meeting with the tail. So we will have to flip this vector. And what is the enthalpy of formation of methane initially? That is delta H1, but we will have to flip it. Minus delta H1, it will be there. What is the enthalpy of combustion of carbon? That is delta H2. Here is delta H2 plus. If the vectors are going towards the same side, from the same side, and if they are even, they are the different one, it's going to make CO2, it is going to make H2O, but their enthalpies will be added up. So delta H1, this is minus delta H1, delta H2, and it is also parallel with delta H3, that is for hydrogen, delta H3, but we are using 2 mole of hydrogen, and this is the enthalpy of formation of enthalpy of combustion of 1 mole of hydrogen. So we will have to multiply it by 2. So there will be 2 mole of delta H3 in this fraction, and 1 mole of delta H2, because we are using 1 mole of carbon, we are combusting the 1 mole of carbon. Now this is the time to find or to write the equation. Finally, delta HC is equal to delta HC, this one, it is equal to the sum of all others, that is delta H2 plus 2 mole of delta H3 minus delta H1. This is the basic answer, and where it is, here it is, D option is the correct option. So with the help of Hess's law, whenever you are given enthalpy of formation, enthalpy of combustion, or any different reactions, or the sequence of, or the different step of a chemical reaction, then you can easily apply Hess's cycle. Come to our next question. Here is another question that is taken from March 19, 1-2 variant, question number 8. Here are basically 3 main reactions. This is the combustion of carbon and formation of CO2 as well, and this is the combustion of hydrogen and formation of water as well, and this is the combustion of methanol, that is over here, I mean -7 to 6. So formation of CO2 is -394, formation of water or combustion of H2O, both enthalpies are same, and that is equal to -286. So 3 reactions are given, and he is asking to find the enthalpy change of formation of methanol. So first of all, I'm going to write the equation for this said reaction. So enthalpy of formation of methanol, CH3OH is the methanol. Here are basically 3 elements. One is the carbon solid, and hydrogen gas, and oxygen gas. So I'm going to synthesize this one. I'm going to form 1 mole of methanol. For 1 mole, I need 2 mole of hydrogen gas, half mole of oxygen gas, and 1 mole of carbon. Now I'm going to connect all these 3 reactions with this blue equation. How to connect? Let's see over here. First of all, carbon plus oxygen goes to CO2. So carbon, here is also carbon. From this box of element, this is the box of element, or you can see the reactant as well. This is the box of product, and here I'm going to connect these two boxes toward the same side. And carbon plus oxygen goes to CO2. So I'm going to write CO2 plus. Come towards hydrogen. This hydrogen is going to meet with oxygen to make H2O liquid. Hydrogen plus oxygen to make H2O. Yes, H2O. And the last one, when this methanol is combusted, it's going to make CO2 and H2O. So this methanol is also going to make the same species, and I'm going to collect them in a single box. So this is the common point from reactant and the product. So overall 1, 2, 3, 4 vectors are lying over here. We are supposed to find the answer of this vector, and we are given for the values of these other 3 vectors. I mean, you will have to suppose that these all reactions are these arrows are behaving like a vector. Now let's see over here. 1 mole of CO2 is being formed. I mean 1 mole of carbon I'm going to combust. Yes, same is the case over here. And so answer will be minus 394. Now come to the next one. Here I'm going to combust 2 mole of hydrogen for the sake of balancing. So there will be 2 mole of H2O, and so double mole of hydrogen value will be there. So if I'm going to combust 2 mole of hydrogen, so the answer will be 2 into minus 286. And I'm using methanol, 1 mole of methanol. Here I'm also using 1 mole of methanol, and I'm going to combust it. I will have to add some more oxygen for the sake of balancing. Total oxygen must be equal to 4. 2 oxygen to oxygen 4. 1 is over here, so 3 by 2 mole of oxygen will be added over here. Same is the case, 3 by 2 O2 oxygen will also be added into this box for the sake of balancing all the root. So all boxes are now balanced to each other. What is the answer of 1 mole of combustion of methanol? That is minus 726 kilojoules per mole. Now this is the time to make to apply the Khizar rule, and here it is. Basically, this is the vector that should be the resultant vector. Its tail is connected with the tail, yes, but its head is not connecting with the head. So I will have to flip this vector. And its answer will also be flipped. So I'm changing its basically its sign, or you can write it minus 726. Now the rest of all answer will be added up. So x is equal to minus 394 plus and 2 into minus 286 minus, I'm going to add it minus 726. So this is the answer of enthalpy of formation of methanol. Which one is the correct option? Over here you can see C is the correct option. So this is the way to solve these sort of question. Once again, if the different equations are given, or enthalpy of formation, enthalpy of combustion is given, or if there is any question where you cannot apply the bond energy rule, where you cannot apply the delta T rule, delta H is equal to MC delta T is not applicable, and there is only one way out to find the answer of that equation, that reaction, that is Hess's cycle. Question number 4, Feb March 21, 2 variant. In this case, 2 equations are given and they are asking to find the answer of this equation. Let's suppose its answer is equal to x, and we are going to find its enthalpy change. Sodium bicarbonate. Here is sodium bicarbonate. So reaction of sodium bicarbonate with HCl is going to make NaCl, H2O, CO2. So I am going to write NaCl. I am connecting equation number 1. Let's suppose this is equation number 1. NaCl, H2O, CO2, and so on. So in this case, basically we are using 2 mole of sodium bicarbonate. So the answer should be multiplied by 2. 2 into minus 38.97. Come toward the next equation. Here 1 mole of sodium carbonate is going to react with HCl plus HCl and 2 mole of HCl, and it's going to make again the same this NaCl, that is in 2 mole plus H2O plus CO2 and so on. So for the sake of balancing, here are 2, so 2 NaCl, I will have to use again 2 mole of HCl over here. So 2 NaCl, H2O, yes, and CO2 from CO3. So now the whole root, I'm going to change them into the boxes. These all 3 boxes are basically balanced in a balanced way. In all these 3 boxes, the atoms are balanced. Now I'm going to put the answer of the equation. When 1 mole of sodium carbonate is allowed to react with HCl, the answer is minus 96.59 kilojoule. And once again, I'm going to apply Khizar rule. What is the answer of this X? It must be the resultant vector. So I'm going to flip this vector to find the answer, and its value will also be flipped. So what is the answer? X will be equal to 2 into 38.97, and the answer is 77.94, and minus, it's a minus, sorry, and this will be minus plus, it will be 96.59. And the answer is 18.65. It is positive, as this is the larger value, positive 18.65 kilojoule per mole. So C is the correct option. That's all about this lecture. Please subscribe my channel, hit the bell icon and share it with your friends. And let me know what is your opinion about this lecture. Are you clear the Hess cycle or Hess law with the help of Khizar rule? Please let me know. Thank you very much. Have a nice day.